Question 3, let's have a look. Let's have a look through it and read through it before we do spoilers. Compounds A, B and C all have the molecular formula C5H10. So C5H10, if you double the 5 and it ends up as a 10, it's got the general formula CnH2n. So it looks on first impressions of it's an alkene. With a double bond. A and B decolorise bromine water, so A and B do have a double bond, but C does not. So that's strange. C5H10, the general formula of an alkene, double the number of carbons, end up with a number of hydrogens, CnH2n, but it hasn't got a double bond. That shows that that can happen if it's cyclic. If it's got a circle, it can have single bonds, but the general formula of an alkene. So C is definitely cyclic, and that will explain why it doesn't decolorise bromine water, but it can have CnH2n as its general formula. B exists as two stereoisomers, but A does not show stereoisomerism. So the double bond. Stereoisomers are geometric isomers at AS level. So geometric isomers means that there's a double bond in there, and the double bond has no free rotation. So what that means is that stereoisomers can have the same structural formula but different positions of atoms in space. And B has got geometrical isomerism, so it means to the left of the double bond two of the groups are different, and to the right of the double bond two groups are different. A has a double bond but does not show stereoisomerism, does not show geometrical isomerism, and so to the left of the double bond two of the groups must be the same, or to the right of the double bond two of the groups must be the same. Let's have a look then at the solution. A and B are unsaturated, have a double bond. Yes, we established that. B has two different groups to each side of the double bond. Could be pent-2-ene. Pent-2-ene, yes. We've drawn actually Z pent-2-ene here. That's fine. Let's just check out that it does have the properties that it describes in the question. Does it have a double bond? Yes, it does. It will decolorise bromine water. Does it have two different groups to the left of on the carbon to the left of the double bond? Yes, it has a H and a methyl group. Those two are different. Let's check to the right. A H and an ethyl group. Yes, those two are different. It will show stereoisomerism or geometrical isomerism. So let's just check out whether it's Z or E that I've actually drawn. So if I go to the left of the double bond and find the carbon there, it's joined to an H and it's joined to a C. So the H has the lower atomic number. H has an atomic number of 1, carbon has an atomic number of 6. So this group would take priority. You'd highlight that. To the right of the double bond, hydrogen has an atomic number of 1. Carbon has an atomic number of 6, so I'd highlight this one here as taking priority. Both groups on the same side, that would be Z pent-2-ene. Let's now have a look at A. A has two groups on the same side of the double bond which are the same, so it could be something like pent-1-ene. Let's have a look here. The carbon to the left of the double bond, yes indeed, does have two hydrogens, two groups that are the same, so it's not going to show stereoisomerism, it's not going to show geometrical isomerism, even though it will decolorise bromine water because it's got a double bond. Let's have a look then at C. C we said is saturated. It's only got single bonds because it doesn't decolorise bromine water. Yeah, it's got the formula of C5H10, the general formula CnH2n of an alkene. So that means that it's cyclic. It could be something like cyclopentane. Single bonds, C5H10. And the definition then of a stereoisomer, a geometrical isomer, is that they have the same structural formula but different positions of atoms in space.